Okay, and here we go. First ever live stream, and maybe the last. Let's see what YouTube Studio is saying. It says we are live and shows me some ads, which I don't want to see, so I think it is working. Don't know if anybody is in the chat, live chat, maybe. Nobody there yet. Can take another minute to set up. Okay, no viewers at the moment. That means I guess I'll wait another minute. Maybe I should have set the category comedy, because it'll surely be a funny stream. Anyway, one viewer joined, hello, and immediately left again. Okay, sorry for that. Good, so my very first live stream, and maybe my last one. What will I try to do? Try to solder this SMD training kit, which is basically an exercise for training SMD soldering. Maybe I get a screwdriver for pointing. So basically you have here 3 rows of SMD components on the left side to solder, 3 rows of SMD components on the right side, and as you can see the packages are getting smaller and smaller. So we start with 1206, then 0805, and on that side we have 0603 down to the tiny weeny, what's it, 0402s, and in the middle we have a small circuit with a NE555 timer IC and CD4017 counter. So basically I think what that thing will do is we will have some LEDs populated there, and whenever the NE555 gets a clock signal to the counter, it counts up, and basically the LED lights will rotate. Okay, oh, hello Alistair. So why am I doing this? Because I tried to do something else entirely. Quick change of scenery. Try to build one of these tiny QRP transceivers for amateur radio, and I somehow botched it because I didn't have the right tools. There were 3 SMD components to solder here. This one, and this one. The 2 bigger ones were no issue. The smaller one is tricky with a soldering iron, or at least it was tricky for me. And at the beginning nothing worked until I realized that maybe from the factory the pre-populated SMD components were not working very well. So I basically, in the end, I resoldered the whole lot, and you can see it's not super pretty. So like here on these tiny capacitors, there's too much solder, but basically I had to manually reheat everything because there was definitely a cold solder joint, so it was not working. Then I got it working for 1 day, and on the next day I was too stupid and fried the clock IC here with the scope probe. So I was probing, does the clock come out, and I somehow shorted out a pin, and this little bugger is dead now. And I basically have to get it off and replace it. So I got a hot air station to do that. But since I have no clue what I'm doing, I thought we start with this training exercise first. Get the board in the middle, and as you see, my camera is also not very good. It's basically an action cam for outdoor use, so it's a bit, you know, I have a bit of cushion view here, but I can't get any closer because then it gets out of focus. So I would really need a SMD USB microscope or something to properly show it. But for the major fuck-ups, I have this cunning technical device where I can show you how bad things are. Okay, so I guess I will start with the biggest components, and I will do the 1206 with the regular soldering iron, and then I will try to do the rest with the hot air station. And now the trick is to know which parts go where. So let's have a look at the schematic here, and I've already sorted the parts a bit. So we have the NE555 timer EC, that one, that goes obviously here. So no guessing there. That's the CD 4017, was it? Yeah, 4017 goes here. Then we have diodes. They're easily to identify, basically just like your box standard 1N4148. They go, where do they go? Here. D18, D19, D17, D16. Then for transistors, those are the LEDs, I guess. Yeah. And have to be careful to solder in the right orientation, because sometimes the green dot is the cathode and sometimes it's not. So we have to better measure those before we get them in all the wrong way around. Okay, and now I have a big bunch of components, and obviously the ones that go into the middle are the important ones, and they should be the right, and the rest, I mean, for these 6 rows on the side, 3 left, 3 right, it doesn't really matter what goes where. So I think, what does the schematic say? Resistor for the LEDs, 330 ohms. So get the magnifying glass out and try to identify the numbers on there. I don't know if you can see that in the video, but here it says 391, which is basically 39 is the number and the 1 is the number of zeros, so 390, which is interesting because the schematic says 330, so slightly higher. Okay, put them to the side. Let's see if we have 330 somewhere, but I don't think so. I think that's the ones for the LEDs. Then we have 10 kilo ohm. 1, 2, 3, 4, 5 times 10 kilo ohm. And here I have 6 times 10 kilo ohm. They are marked 103. So 10 with 3 zeros should be 10 kilo ohm, yeah. Why do I have 6 and the schematic says 5? 1, 2, 3, 4, 5. and don't know, maybe one extra to get lost when I blow it away with the hot air station. Then 2 capacitors, 0.1 microfarad. I guess these are those, because that's the only component where only 2 parts are in the belt. The cat's going crazy behind me, that's why you hear scratching. And then we have 2 more, which is 205. 205. What is 205? It is 2 mega ohm, right? And I only need 1. I think that's just the configuration for the timer EC. So 1 extra again, which I can't see where it goes at the moment. Okay, which basically means all the remaining parts must be the parts that go on the side, on the left and on the right. And at least for the 1206 it's easy because that's the biggest component. So I'm pretty sure we can start with this, because that's the only component in 1206 form factor. Wrist strap, yeah, sorry. Good idea. Before I unpack the buggers, I have one. Wrist strap. Of course it is. Yeah, I need to get a different clip, because my electrostatic mat has in the corner a clip. It would be much nicer to, clip to that than going across the table. Somehow the cable is always in the way, and it's basically next to my soldering iron, so I will melt it. Okay, then I guess let's get started. So I have one of this JBC soldering irons, but you don't need a JBC soldering iron. You can basically get on the internet something, I think it's called T12. Basically, the handle is what you buy from JBC, and the cartridges is what you buy from JBC. And the station, you can get a cheaper clone, and it'll do exactly the same as the JBC station does, but cost you a fraction. Okay, so now the question is, what soldering tip are we using? So very fine pointy one is not a good idea, because you have to get the heat down. I think this one is already a bit mangled. It would work. The chisel tip would probably be my preferred choice, but I also have a tip with a dimple here, where basically you have a reservoir of solder, so you can just take your, that's lead-free solder, by the way, so it will be another funny exercise that I've never done before. So you can basically melt here a little bit in, and then clean your tip, and then melt in again, and now you would be ready to solder. But of course we have to open the package first. So I need pliers. Where's my pliers? Here. Let's see. And of course, now's the time where one of these bits shoots across the room and disappears in the carpet, never to be seen again. I'm not very good in opening this. Okay. Not elegant, but it's open. So we have 2 resistors, and we just place them here before they get lost. Oops, And that one, you flip it around as well. Okay, so basically there are various tutorials how to do this. I mean, this is already pre-tint, and I guess it's also, it looks shiny, so I guess it's leaded solder, but let's just start with the one in the middle for simplicity, add a bit more. So now we have the one in R6 already tinned, and the idea is to basically, you know, heat it and slide it over until it sits here in the middle, and then you have one side already soldered. Let's see if that works. I don't know. Let's see. Okay. And of course it doesn't look nice now, but we'll fix that in a second. Let me do a second one. Let's do the one above. And slide it in, and I have absolutely no clue what I'm doing here. It's just what I learned from watching YouTube videos and failing. Okay, so one side is soldered, but it looks ugly. The other side is not soldered. And this is where the extra flux dispenser comes in, which really helps flowing the solder. So let's, I mean, this is a, what is this? Atten FL22. And then I also have a Flux Pen, Flux X32 stanol. So this is liquid, and this is more like gooey stuff. The gooey stuff I like quite a lot. I've used it. So just a small amount of flux here. Well, according to Louis Rossmann, a lot of flux, so maybe let's add here as well. And now I guess we should solder the other side. So I'll flip this around. Extractor, yeah, extractor, very good. I don't have an extractor, so I will inhale unhealthy stuff. But as this is lead free, I hope I will survive. But yeah, I should also get one of these sucky extraction hoods. They don't cost a lot. They just have a what is it? A carbon filter in, and then you're not, you know, inhaling poisonous gases. Okay, so let's see. Tin this. So let's try this two ways. Let's fill the dimple here and just tap it without any extra solder. See what happens. It's not too bad. It's not 100% straight, but this is what you get with hand soldering. And you see the basically solder transferred from the dimple here to this. And of course you can also do it like this. You can, if this would be a chisel tip without dimple, you would probably do something like this. Heat it and done. Okay, and now the other side. I mean, we've already soldered the other side, but it looks ugly, and with the extra flux I think it will look much better. We just tap it and once more. Well, that looks really nice. Okay, so these ones don't look too bad, and what you do then is usually you get some isopropanol, which is far away, and I'm tied to my desk with the wrist strap. So let's see. Okay, I have some cloth here, because when you do it with paper, you have all this paper residue. So you basically just, you know, rub it off. And I'm already feeling that this stream will take ages. How long are we running? Since 20 minutes, and I've already managed to solder 2 parts. Fantastic. Okay, we'll be in here all night. No, maybe not. I guess I'll do 1 row here and 1 row there, and then we see if we continue or not. Good. So yeah, now let's get the dirty magnifying glasses and have a look. How does that look? You can't really see it. No. No, I don't think you can see it. Now, let me do this. Let me zoom in on my laptop, and then I can get a better view what you're seeing. Okay, I think this is as good as I can show you. It's not super pretty. A bit too much solder here on this one. But here the left side looks okay, I guess. So, where we can try to fix the too much solder problem. Again, just add flux. Take the soldering iron, clean it, maybe not fill the dimple completely, and we just drag across. Yep, I guess that helped. So we got the excess solder off. Cleaning again. Yeah, I think now I'm happy with that. So I guess we'll do the remaining ones. Maybe a bit faster. Where is my... Let's do the next 2. And of course these rails are for pick and place machines, so always nasty to get stuff out. So 1, 2, 3. And clean the solder tip. So 3 pads tinned. Okay, heat it and slide it in. Heat it and slide it in. Heat and slide it in. Okay, well, with the 1206 that works quite well, I must say. I think I'll do the remaining ones and then solder the other side in one go, otherwise we'll be here all night. So, get 3 more. The interesting experiment is how much easier or more difficult is it with the hot air station. Okay. Tin it, tin it, tin it. Let me do the ones here as well. And of course, if you're soldering SMD, it's good that you're not using the thickest solder. So this is Gubei 0.35 millimeter. And here I have the ones that are the normal ones, normal solder for leaded, for components with wires. So that's 1 millimeter, and I guess that would be, if you see here, would be too big. So what is Alistair asking? Let's have a look. Can you tin both pads and place the component on top? Push down each side with the tip of the iron. Yeah, can try that. Let me solder these 3 ones. We tried with one of the remaining ones. I don't know if that, it depends. If you don't have too much solder on, it'll work. But if you have both sides tinned and a lot of solder on, then you might, you know, first it goes like this, and then you try to push it down like this. And then I don't know if it's, depends. Let's see. We'll try it. Why not? I mean, it's a practice board. That's why we do this. So slide it. In theory, I could also try one. Now I've tinned everything already. But I could try one without this extra tinning, just heating what's already on the board. Maybe that's already enough to get the component on, and then we just reflow it later. Good. So what have I done? Have I forgotten everything what I've told you? Yes. So let's see. Basically, yeah. Oh yeah, I think I should also try the Flux Pen to show you the difference. I think this one is really nice stuff. I'm happy with this one. That's the Flux Pen, which is basically, there's a liquid and there's like a felt tip with a ball pen, and when you press down, then the liquid gets out. So you can basically press down gently. Yeah, you see there's already a lot of liquid coming out. That was already too much, I think. So flip it round, because you've only tacked the one side, and I think I have to clean the tip, solder, clean it. Good. Now let's see. Yeah, it's makes noises now because it's liquid, so you don't get that with the gooey stuff. Okay. And you can, on the other hand, I think it lasts a bit longer because, right. Okay, and then just heat the other side. We've done those two. This one needs reheating. This one. Whoops. See, I've done something wrong there. I did not properly solder it on. The other side was not properly fixed. So obviously when I reheated it, floated away. But with 1206 components, not a problem. Okay, then. Clean the mess off. They will all work, but yeah, I think, no, it's not too bad. I think it's okay. And I'm still not used to lead-free solder. I've used up my dad's old leaded stash. And then I decided, okay, I've inhaled enough of this. I go lead-free, but I have to still get used to it. Oh yeah, when you're wondering, I'm soldering here with 350 degrees, which is maybe, I think you could also go down to 325, but at least for this size, I think 350 works. Okay, so we have 1, 2, 3, 4 more to go. But I think we have 1, 2, 3, 4, one resistor extra. So maybe if we lose one. So I guess since I don't intend to lose one, let's cut this off. And yeah, now careful that I don't lose one. Shoop. Okay. And of course I'm picky. I'm aligning the numbers in the same orientation as the silk screen. No sane person does that, but I can't stop myself. Oop. So sort the bits. Nah. And get some proper pliers. Nothing worse than bad pliers, I tell you. So don't get the cheapest stuff from eBay. Okay, we have 4 more resistors to go, and we wanted to do the tin both sides and press down. Okay, maybe I should also switch tip now, just for fun. So this was the dimpled tip. Pull it out and take, yeah, let's try the very fine one. And that tip is also pretty old. I got some tip reactivator as well, which I've never used. Maybe we should try that, since we are doing all kinds of weird experiments. So I don't know how that works. Maybe you clean this and then you push it in here. I've never used one of these tip cleaning things. Not sure how that works. Maybe just push it in and you can clean it off. Yes, I guess it got rid of a bit of this colophonium gunk. Let's try one more. Push it in. And, well, it's not brand new tip, but it looks better than before. Good. So now with a fine tip, well, it's still a chisel tip here. I think it's 2 millimeter, so it might be good for the 06, 03 components here on the other side. But let me show you how that works with the 1206. So as you heat it and slide it in. Okay, well, that worked. But a very, very pointy tip is maybe not so good. So I think bigger is better, despite it being SMD. I mean, not 10 millimeter, but you know, a flat tip which has the same dimension as the pad you're trying to solder. So here it's already too small, almost. Okay, and we wanted to do the seesaw method, so tin both sides and push down with a soldering iron. But okay, let's do that here and here. So basically put it on top, and then as you see, it's almost a tombstone. Now flip it round. Nevertheless, I should give it extra flux. It's always good to do more flux. So I think which ones were missing? The 4 on the top, I think, here. So I don't know if you can see that. That you basically, if I angle this, you see that they are not. No, you don't see it. Let me try. I don't know if you see that in the video, but the tools where we tint both sides and pressed down, they're obviously not lying flat, because the one side where we melted is lying flat on the PCB, and the other is sitting on top of the solder. So I think let's try. Because now I can press down, but the other side is already solid, yeah? So I don't know if that will work. Let's see. I guess with the hot air station it doesn't matter. If we afterwards go over all this with the hot air station, then it will all self-center due to surface tension. But if you solder it just with the soldering iron, maybe the sliding in method is better, but you need the space. Obviously here it works, but if you have a densely populated PCB, sometimes you cannot get in. So let's see. Which ones were the ones where I did that slide in? I think these two, right? So the idea was press down here. Not sure. Obviously you don't want to crack this. And since this has no dimple, you have to really get extra solder now, because it doesn't have this extra pocket to hold basically a reservoir of solder. Oop. So let me have a look. How does that look like? Yeah, you still see that they're they're not as flat as the other ones, but I think all these connections look okay to me. But of course, if you hand solder it and hand place it, it will never look super pretty, because you just can't get it 100% straight. Okay, well, that was one row done. So which one is the prettiest? I don't know. Maybe 5 and 6 where I started, because I spent most time on them. Haha. Good, so that was one side, and I guess we should try now a row with the solder paste and the hot air station as comparison. So let me, yeah, I didn't use the big chisel tip. Okay, let's switch tips once more. Oops, and now I knocked the camera. Ouch, don't get seasick. And put the big chisel tip in. And now I need one more part to solder for the big chisel tip. Let's solder, and no, not a whole row. Let's have a look. Maybe Yeah, the 2 mega ohm resistor R49. Where is that? R49 here. And the schematic says 2 mega ohm. So I have to find it. Probably already knocked stuff down. Yeah, there it is on the floor as expected. And what does it say? It says 205, which might be 2 mega ohm. So let's maybe cut that in half and not cut myself and not send it flying. Okay, where did I put my tip cleaner? Here. So I don't know what that is. It looks solid, but it has loose bits as well. So first of all, secure our resistor, then clean the tip and put it into the tip cleaning. Oh, that was not too bad. It looks much nicer than before. Needs tinning, of course. Okay, yeah, well, still a used tip. I have a new one here. So this is how it looks like when you buy it shiny new from JBC. Let's open it. I don't want to use this right now, but this is how it looks like. This is how a brand new one looks, and this is how a used one looks after a while. But the temperature control is really good on this G12 tips. I got one of these cheap soldering iron temperature meters from eBay, which have basically, let me show you the thermo element here, and you basically switch it on, and then, I mean, the JBC doesn't even have a method of calibrating, because it's, I mean, if you set it to 350, it should be 350, but I have another soldering iron where you can calibrate, and what you basically do is you tin your tip a bit and put it here, and then we see that it is not 350, but you don't see it, I see it, because it's out of screen. Hang on a second. Move this thing out of the way. And put your tip on here. Okay, so that is a bit over the top. Set to 350. And it shows 364. I tried it with a different one, and it was basically exactly 350. Mind you, this is also a bit of a old used tip, maybe that's why. But yeah, basically you could, even if you can't calibrate, you could basically, I mean, the question is, what do you trust? Do you trust your soldering iron, or do you trust this thermocouple thing? But here we see, okay, it says 360, so we could basically go 10 degrees lower, And what does it give us? Yeah, now I've set it to 340 and it shows yeah, 344. I guess plus minus 5 degrees is okay. But why not? Let's try that. I also wanted to show you lower temperature, yeah. So I set it to 325 now. Maybe a bit more. Solder. Okay. Set to 325, showing 340. Okay. Good. Well, as I said, don't know how accurate this is and don't know how accurate the JBC is. But I tried a brand new tip a while ago and it was more or less spot on. So set to 350, showing 350. So yeah. Okay, so back to our exercise. Yeah, and I also have a few replacement sensors because after a while you have, you know, solder on here and I don't know, maybe they don't work as good as before. Good, then small detour. I don't know, nobody needs one of these thermometers, but I was, I think I had one of these ERSA RDS60 station, still sits here around the corner. And it has a calibration, and as a kid I managed to completely, utterly detune it. So I had no idea which temperature it was at. That's why I got that thing for a few bucks. Okay, so I'm dragging it out with the hot air station, am I not? So let's see. Back to the task at hand. Double check. What do we have here? 205, yeah. It hasn't changed since I moved it around, which is a good thing. I have to open the foil on top of this carrier, which is not so nice. Come on. Get off, you bugger. Ugh. Maybe fingernail, it's easier. Now I've cut it and only a single resistor is... Let's try from the other side. Now it gets off. Right, I have it. Nah. Come on, get out. It does not want to get out. I mean, as you see, there's also now smaller form factor. I don't know, what is that? 0603. Hi, John. Just rambling on here on my own. Nobody's. That looks odd, isn't it? They got me a 2 mega ohm resistor, which should be put here. No, it's okay. I thought it's the wrong size, but it looks okay. Good. So let's try with the big fat chisel tip. Should I measure it before I solder it on? Where's the fun in that? Let's put it on. So R49 according to the schematic. Tin it. And then use the same method as before. Did I tin the right side now? Yeah, I think so. Did I? Basically heat it and slide it in. Okay. And oops, a bit of flux on the other side. Well, on both sides basically. Okay, that was a bit too much, but there's no such thing as too much flux. Clean the tip. And it's a bit tricky for me because I'm looking through the ring light past the camera, and I'm also not in the center, so maybe like this. I think that worked. Clean it off with IPA and inspection. You see just the reflection of the ring light, not really my bad soldering. I should get one of these 70-80 bucks USB microscopes, and you have video out and it's much better to see. But I think it looks fine. So as you can see, even with this tip, which is, well, actually I would even say that's the ideal size for this kind of pads. So yeah, that worked quite nicely. But with the tip with the dimple, you have the benefit that you have a bit of a reservoir. So I think I should go back to this one, but anyway, we wanted to test the hot air station. So enough of regular soldering. Let's clean up here a bit and try to move to the hot air station and see how successful that is. So put, oh, my desk is really too small for what I try to do here. So okay, bit of cleaning up. So these are my two new tips. The only disadvantage about the JBC 245 cartridges that they cost quite a bit of money. I guess it's around 30 euros per tip, but they last you a long time. So, and the good thing is, since the heating element is in the tip, when you get a new tip, you basically have a brand new soldering iron, so you don't yeah, you pay extra, but I think it's worth it. Okay. Right, so switch off the soldering iron, and thanks John. Audio and video is okay. Yeah, I think a lot of people use one of these lamps with the magnifying glass in the middle. So magnifying glass in the middle, and around you have like a ring light. I think I should get one of those as well, or the USB microscope. Okay, so that was the soldering tip rejuvenator. So that works as well, but I don't know how long it lasts, but I think it helps get off old flux. So when your tip has a lot of old flux that you cannot get rid with the brass sponge thingy, then that helps. So I thought I'd give it a try. Okay, then hot air station. I don't know how to start. And since I'm a chicken, I will start with the big components as well, because I have no idea how that will work out. So basically I got solder paste, and since I have no clue about solder paste, I Just got something from eBay. And luckily it's not old. Its manufacturing date 25th January 2022. And when you Google on eBay, at least on no, not eBay. I got it on Amazon. When you look on Amazon, the first thing you find is low temperature solder. So something which is not regular solder, but especially made for reworking, with much lower melting point. But since I'm not reworking, I want to solder normally. I try to get a normal paste. So here, that's the data sheet for that thing, or the heat reflow profile basically. So it's SMD 291SN SNL, maybe this one. What does it say? Yeah. I mean, it's basically the same stuff as I have here, I think. This is, oops, now I've uncoiled all my solder. So I think this one is also SNAGCU, so basically box standard lead-free solder. And I think, yeah, here you see below, here's the datasheet for the low temperature one with bismuth, I think. And they have melting point of 165 degrees. But I think I have the box standard one, which says, okay, 250. And that's the reflow profile when you put it in a, reflow oven. And then you use the hot air station. I think you have to go higher. So when this one says 250, you probably have to set the hot air station to 300 or something. I don't know. I've never used one, so that will be funny. And of course, you know, the hotter you go, the quicker it basically melts, and the quicker you can get away with the hot air. But I guess it's a bit of experimentation needed. What's the sweet spot here? Anyway, solder paste and some parts. So I guess what we should do, maybe clean the pad with IPA before. I didn't do that for the hand solder jobby. So let's try this row here. Maybe 0805 is still doable for my old eyes. And then you basically have to put solder paste on each of these pads, and then you press the component into the paste. And then comes the hot air station, which hopefully does not blow off all the bits. And yeah, let's see. I have no idea how this will work. So let's see. This is completely new for me. I've done a few SMD components by hand with a soldering iron, but let's see. Gently. I think it still has to go through the nozzle, but I don't want a big squirt of stuff coming out. No, don't see it yet. No. There's something coming. I don't know. Oops. Yeah, exactly. That's what I wanted to avoid. We have a big blob here. I guess better clean it off with some paper. Okay. And then no idea how much or how less solder paste you need. I guess a small dab, the last dab. No, that is a different show. Yeah, that's not. I got this on Friday and I didn't put it in the fridge because I knew I would use it. So you have to store this stuff in the fridge usually. And it has an expiry date. So yeah, but I think this, I have no idea how much I really need. It might be too much already. But I think it's a mixture of the solder and flux. Okay, flip it around. It's probably the most boring stream. I have no background music. I have no fancy icons. I have no giveaways. Haha. It's just an experiment. Because I have all these toys lying around. I should all use them at once. The camera, and the hot air station, and the ring light. And okay, I guess we've made a big mess and we've used far too much solder paste, but it's an experiment. So now I need 0805 resistors and not the ones that I need in the middle for the real circuit. So I guess, what do we have here? 515. What is 515? Uh, 5.1 mega ohm. I don't know. Probably nothing I need for my circuit in the for my ring light in the middle. But anyway, we also wanted to check the one resistor that I've soldered there. So let's get a multimeter, cheap ass multimeter, ohms, and see what we've soldered on there. I hope it's 2 mega ohm. And wow. Okay, well, that is 2 mega ohm. That was a surprise. Good. Okay, then let's also measure the other ones. I think they are just sending random parts for these 3 columns here on the left and on the right side, but oops. Get the bloody plastic off. And of course I can't measure this here because it's metal, so it's still on the video. No, you can't see it. Here's my resistor sitting on the bench. Just want to know what value it is. Gently. Okay, I was right. It's 5.1 mega ohm. So okay, and put the multimeter away and place all these SMD components in the solder paste. And I'm pretty sure I used too much, but I don't know, maybe that was the wrong tip. It also came with this plastic one, but from the diameter it looked pretty much identical, so I used the metal tip. Okay, and now place this in the solder paste. Yikes. Scary stuff. I don't know. Okay. And I guess all of them should be placed, and then we come with the hot air gun and blow it across the room. As I said, I've never used a hot air station, and this is training for having to replace one of these tiny clock chips on this board. I mean, desoldering is pretty easy. I mean, you just, you know, heat it up and wait until it melts and you pick off the part, but desoldering is trickier. So, yeah, I don't know. I think it will make a big mess. I mean, it depends. I really don't know how much flux is in this paste and how much solder is in this paste. Maybe it's just, it'll sort itself out. Any more comments in the chat? No. 2 lonely warriors watching, or maybe letting it run in the background. That's perfectly fine. Oops. And okay, placed 4 so far. More to come. I think I was the wrong orientation. I am too picky. I have to. It has to align with the silk screen. This is just something that will drive me nuts later. I'm not sure if that works. Because now on this one I have smudges of solder paste below. But I hope with the surface tension it will all sort itself out when I heat it up. And of course now I have goo on my pliers as well. Come on. Yep. Yikes. Right. I can clean my pliers quickly. Haha, yeah, I'm also excited how that will work. And anyway, it was a complete, you know, I don't know. Let's call it long-term investment, this hot air station, yeah, because I mean the kit that I'm trying to build cost like a third of what the hot air station cost, but what the heck. It's a hobby, and I thought if it works well, it's something that I can always reuse. On eBay you also find cheap hot air stations where they have the heater and the small fan. It's all in the handle, costs about I don't know, 40-50 bucks, but I watched a few teardowns and that put me off buying something for 50 bucks that is potentially killing me. You know, it's super cheap, and on these hot air stations, I don't know, let me quickly show you. They are huge beasts, yeah, and they have here basically a heater which is on mains voltage with a triac controlled. So if this is not properly built or dodgily assembled or whatever, then you suddenly have, you know, live 230 volt here in Germany on your tip, and I chickened out. Of course you can buy it cheap, can open it, can check it all that it is safe to use, but I thought, come on. It'd probably annoy the hell out of me if it doesn't properly work, so I got a slightly more expensive Atten, which is still considered the cheap option. I I basically looked on eBay what one of these JBC hot air stations costs. I think if you buy a JBC one, it's like 2,500 euro. And on eBay I found used ones, but without the heater cartridge. And then I said, okay, when I get a used one, I'm paying 200, and the new heater cartridge is also 200, and then you're at 400 euro. And the Atten costs around 235 now. And another famous option, favorite option is a Quick Hot Air Station, Quick 861DW, I think. That looked really good. There's a tear down from EEV block, and that looked really like a nice machine. You know, everything properly isolated, heat shrinked, cable tied, etc., etc. Nice mains filter. Costs 300 bucks. So in a way, I didn't spend the 300. I spent 235. So compromise. And oops, wrong orientation. I'm not sure if I'm much faster this way, I must say. I mean, basically with soldering, just do it bit by bit, and here you have to place everything, and then in the end you put the hot air nozzle on and solder everything in one go. So I don't know if it's much time saving. I think it is much time saving if you order a PCB and get the stencil, which is like a thin metal sheet which has the holes in the right place. So basically you then can just, you know, put the stencil on your PCB, use a, you know, credit card or something to spread your solder paste, and you basically spread it on and go swoosh, and all your pads have the exact right amount of solder paste on. And then basically you flip your stencil off, get the second PCB, flip it down, and do the same. So you can in one go apply solder paste for a number of PCBs. So that, I think that's when you really have time saving. Doing it here with manual dispensing, it's maybe not super efficient. And again, we got one resistor extra if we lose one. So that's nice. These solder training kits are really cheap. I guess I don't know what this one costs, 5 or 6 euros. So it's really like, you know, they're mass produced and really cheap. Okay, so now I have to plug up the courage to switch on the hot air gun. Now, first of all, find out which nozzle I should use. Any recommendations, guys? I have no idea. Oops, and I've whacked the camera again. So now go with the smallest. This is the smallest, medium, big, and I have even bigger ones, but I think maybe one of those is probably good when solder a complete IC, but maybe the middle one. Any ideas? Maybe this one. Probably doesn't matter for 0805s anyway. I'll try the middle one. Let's see what happens. Okay. And the question is now, okay, just reading your comment, John. Thanks. Yeah. As I said, every failed project is a chance to buy new nice tools. So you have to not be depressed when something goes wrong, because there's always a chance to get new nice tools. Okay, so what temperature do I need now for this thing? The reflow profile here says 249. I mean, this is for the infrared oven, so I do a slow ramp up, probably that any moisture goes away before it could crack any chips. But I mean, with resistors we don't have the problem. And then I think here between 210 and 270 is the reflow phase, and then it cools down again. But with a hot air station, don't know. Let's try 300, I would say. Bang in the middle. So 300. And the question is which airflow? Because when the airflow is too high, I will blow my bits around. Don't know. So how would that work? Like this. It's not on yet. So just you will hear it when it is on. It makes a bit of a noise. Yeah, I guess. Let me see. I'll press the button. Let's see what happens. And okay, yeah, it's quite a lot of. I think I should go lower with the airflow. That's 45%. Let's go 40. And I have no idea. Yeah, it's too much. Too much. Let's go 30%. Yeah, see, I'm blowing it already around. I already see it. It's already wandering off. Alistair, you have the Atten as well. Any airflow recommendations? I think I go lower. %25 now. And of course I don't have an angled nozzle and the camera is in the way, so I have to aim it in an angle, and then the danger is that stuff blows away. See, I'm not making, it's not good what I'm doing here. See, it's this is not good. So what does it mean? Maybe the temperature is too low, because if it has time to not melt, let's try higher temperature. So 325 now, and still 25% airflow. I'm just I'm not making any progress here, I think. See, it's all just getting a big gooey mess. This is what I expected. It doesn't work, but it's my first try. Good. Maybe take the smallest nozzle instead of this one. So it's cooling down now, but I guess I have to wait a minute or two before I can change the nozzle. So when you switch this thing off, the fan ramps up to 100% to cool down the heater. And then I guess when it drops below 100, when it drops below 100 degrees, it switches off the air. Okay, well, what have we learned so far? That my temperature is probably too low. What do you reckon? Yeah, I think the temperature is too low because it has time to, I mean, it's heating up, but too slow, and then you blow the paste around. Okay. I guess. Yeah, try the smaller nozzle and maybe more heat. I don't know. It's my first time I'm using this paste. I have no idea what it likes. Okay. And how does that work? Yeah. You're not seeing what I'm doing right now. There's a stand provided with the Atten, which has one of these metal clips where you can basically pull off the nozzle without burning your fingers. So the pulling off bit worked. And the putting on again, I must be quick before it heats up. Okay, so now I have the small nozzle on. Yeah, no problem, John. I don't know. It's just for fun for me. If anybody wants to watch me fail, it's good. But thanks for dropping in. Yeah, have a good time. Okay, so next experiment. Maybe go crazy and try 350. I mean, what can go wrong? It's just a bloody resistor, yeah? At the moment we are not soldering. Yes. Okay, yeah. So obviously smaller nozzle, automatically more airflow because with smaller diameter. I'm not... When does this bloody soda paste reflow? What am I doing wrong here, huh? It's just drying up now. Come on. Did I buy the wrong stuff? Maybe I should Google this, because it's not exactly the same number. 29 1 SNL. Yeah, that must be this one. And T5 is the size of the solder balls, basically. So there's T4, T5, T6, and I guess the higher the number, the smaller the solder ball. So, right, that is not working well at all. Okay, I guess. Yeah, but here it says reflow profile 250 degrees, and I've already set it to 350, and the stuff is just getting blown around. So maybe even less air, 15%. It's not as easy as I thought it would be. It looks so easy when Mr. Louis Rossmann does it, but I guess he has decades of practice and I'm just an idiot. See what is happening here. Nah. This is not working well at all. Okay, well, it not working is also a result, but aha, now we are talking. Yeah, I think what it means is more heat. 350 is maybe not enough. Okay, then let's readjust the bloody mess I've made here, and let's try with 400. But I think it's exactly the bit that you have to figure out with the hot air station. How much airflow and what temperature works best for the parts and your solder paste that you are using. And I think more heat means it has less time to blow your parts around. But when you go with a smaller nozzle, you also have to reduce the airflow, otherwise it also blows your parts around. So I don't know. Tricky. Okay, so here we go again. So let's go crazy. Let's set our temperature to, well, maybe not 400. Let's try try 375 and see if that works better with 15% airflow. But airflow is also maybe still too high. Let's see. First let's... Okay, it's reached temperature. And... See, it blows around. This is not good what I'm doing here. Okay, what the heck. So that's now set to 400. But of course I have a complete mess here and the paste is almost dried up. So it probably doesn't reflow properly anyway. Let's try the one in the middle. Nope. I'm not... 10% now, 400 degrees. Haha, that's a really nice mess that I've made here, isn't it? And they just keep all wandering around. So what have we learned? I've used far too much soda paste. Yeah. I'm not sure if this is healthy temperature for anything else but resistors. What a mess. So now you know exactly how not to use your hot air station. Bloody hell. I think it's still... Is it still too much airflow? Or maybe I'm too close to this thing, but I don't know. Maybe my feeling to go close is wrong. Because I have the urge, like with a soldering iron, to get close to the component, which is maybe wrong. I don't know if you can see that in the video. Well, he somehow got it on, but it is a real mess. Made a real ugly mess here. I guess it's isopropanol time again and see how bad it looks. I think, I don't know. So if anybody watches this disaster video after the fact, please tell me what I did wrong. Should I use a bigger nozzle? Or even less airflow? Or high temperature? But somehow This is not, yeah, and it's super hot. The components are super hot, but maybe I should have gone with the low temperature solder. I made a right mess here. I think my cloth that I used for the IPA is now also, it's time to ditch it. Okay, so okay, well, that does not look good, does it? I think my hand soldered bits look better. The only benefit here is that it's somehow self-centered, but yeah, I think way too much solder paste used. Maybe that was the first mistake. Interesting. Okay, I guess what I will do is, here in the middle there's capacitors to solder. So let's maybe try with less solder paste to solder one of these capacitors on. Get one out. So now the question is, how do I dispense less solder paste? Well, maybe when the heat is higher, it will flow better. So I don't know. Let's see. Let's try to get really just a tiny amount of solder paste. Well, that's less than before. And then put the capacitor in the middle. And then what temperature do I have set? 400 degrees and 10% airflow with the smallest nozzle. Is that the right nozzle for this job? I have no idea. I mean, in a way, it should heat both pads at once. Maybe I should go back to the bigger nozzle. Okay, let's try. Maybe go too bigger. Maybe obviously bigger means it heats a bigger area. Let's try this. Maybe I just completely getting it wrong how this should work. I mean, it's not a soldering iron, so why should it need a fine tip? It needs to heat. Heat the complete area. So maybe, don't know. So let's try 400 degrees, 15% airflow. Oh, I think Alistair has also given up. It was too boring, but let's see. It's not so loud. I mean, at least at low airflow, the Atten is not so loud. So let's see. Okay. I think Now we have not enough airflow because the nozzle is bigger. So 25% now. Ah, well, that looks much nicer, doesn't it? Almost acceptable, I would say. Okay, let's try that again. So, less solder paste, bigger nozzle to heat a bigger area in one go. So, yeah. I wonder how I will ever solder a fine pitch SSOP package with this. It's a challenge. Okay, I think the board was still so hot that this time my solder paste basically liquefied when I touched it with the metal tip, which basically means I might have the right amount of size in. So maybe you should preheat your board a bit. I mean, the professionals put it on an infrared plate, I guess. So there you go. Second capacitor placed. Let's try that again. 400 degrees. 25% airflow. Three, two, one. I think no, hi Alistair, I have not finished yet. I'm making a pig's ear of the solder paste dispensing. So I tried to do this row, put all the resistors on, put the solder paste on, and then everything just blew around more or less. So I think it was the wrong combination of airflow, temperature, amount of solder paste, and me being too dumb to use the machine. And now I'm doing experiments one by one with the capacitors here. It's not as easy as Mr. Rossman makes it look like when he switches parts. So I don't know. Maybe it's my paste, but I got a T5 paste because people said a T5 paste flows better. But okay, let's try it again here. Paste and the capacitor, and I'm pretty sure I've not found the sweet spot how this works yet. I'm probably torturing these components quite badly. I don't know what happens with my SI 5351 when I treat it like that. Probably fries before it even reflows the component. So we are at 400 degrees, 25% airflow at the moment, and a quite big nozzle, as you can see. Because with a smaller nozzle you get even higher airflow and the parts fly around even quicker. Okay, that kind of worked, but it's still pretty slow. I mean, it says the paste needs 250 degrees to reflow, and I heat it here with 400 degrees, which is already a bit strange, I think. Anyway, just for fun, we could try 450 and 500. I mean, these capacitors here are anyway not connected, so I can mistreat them in any way I want. And yeah, that's and when the board is already preheated, basically your solder paste flows, so you have better chance of dispensing a smaller amount of paste. Well, that was already too much. Okay, let's better stop here now. And let's see, after I've made such a mess with the row of resistors here, I'm putting, you know, populating every second one and leave a gap, because then when the stuff moves around, I'm not messing up everything in one go. So what can we do? Let's try $425 and 25% airflow, which is really feels really ridiculous, but I don't know. So 425 degrees, 25% airflow, and come on, dear capacitor. Don't know. Managed to blow the one on the top around. I think I'm aiming wrong. I'm probably, because I'm looking here through my ring light with the camera, I'm misjudging where the hot air hits. Let's see. But 425 degrees is like really I don't know. I still think this should work with around 250 degrees. Maybe get the airflow to 30. So 350 degrees, 30% airflow, and aiming very badly. Yep. Yeah, and of course maybe I should give this thing just a bit more flux. Flux is good for everything. And then let's reheat it, especially that one. How long is the stream already running? Nobody will watch this. 1 hour 45. Okay, well, I guess I finish this row of capacitors and then it will have run for 2 hours and nobody will anyway want to watch this. So, the board is hot, but the solder doesn't flow. Maybe I should have gone with the low temperature solder paste. Maybe going for the regular one was not a good idea. I don't know. Maybe I'm using now the solder paste that you use for, you know, big fat connectors, or I don't know, not for SMD parts. I mean, I have no idea. Okay, so let's finish this row and call it a day. What time is it? Okay, 9:45. Then see, the board is still so hot at my solder paste turns liquid when I touch it with this metal. Here you see it really. So it basically liquefies when I touch it with the metal syringe. And here it's not so hot, so here you have a big fat blob. Good. Then let's put some more capacitors on here. Oh yeah, that really made a mess already. Look at that big gunk of solder paste. Maybe I got the wrong solder paste, but I thought, hey, exactly the same that I use with conventional soldering. Why would I want anything with bismuth or something like that to lower the melting temperature? But maybe I was wrong. Anyway, as you can see from the size 1206, 08, 04, 05, it's basically not a problem. I think hand soldering, so far hand soldering is easier because don't know what I'm doing here. And I think we have 2 more capacitors left, and there's again 1 spare. It's actually quite a nice kit. They give you 1 spare bit to loosen the carpet or to mess up. And of course everybody wanted to see the LEDs rotate, but I think I need to take my time to get accomplished with this hot air station. So, okay, so we've placed all the capacitors. And maybe the airflow was still too high. I'm going back to 25. Let's see. Still playing around here. bit clueless. Let's try 375 and 25% airflow. Okay, and maybe a bit bigger distance so that it doesn't wander around. So it's still still wandering around. Yep, and now it popped off. Haha. Okay, see, I think I don't know, maybe that's really odd. Hey, if it says here 250 reflow profile and I'm heating here at 375, that's yep, now see, now it pulled itself in place, but it took ages. Odd. And the one next to it has already wandered off. See, the complete solder paste dried out. So I've basically dried it out and then it doesn't work anymore. Okay. So 385 and 25%. No. This is not working as intended. And now, see, now we have reached boiling point. Zack. Maybe I'm just not patient enough. Okay. And have we reached the 2 hours streaming time already? Almost 7 minutes to go. And of course it's now super hot, so it will make hissing noises when I come with my IPA. So I don't know. Maybe you think it's my clamps here, my metal clamps, that dissipate so much heat? No. Okay, so final inspection before we call it a day. We've managed to solder 25 resistors and 12 capacitors in 2 hours. Amazing. That can't be good, can it? So, see? Zoom in for the final inspection of this disaster. Yeah. And I can see how that looks. So fantastic manual zoom The left row was hand soldered, and the right row of resistors had much too much solder paste, and in the middle I had random experiments with less solder paste and more heat and less airflow and God knows what, but I think, let me look myself, yeah, I mean, it's definitely less solder paste, maybe not enough this time. So somewhere, if you look at C2 and R4, R4 has much too much, C2 has not enough. And it took ages for me to heat up the board, maybe because I'm not looking straight. I'm looking at an angle, I'm holding the hot air station at an angle, maybe I'm misjudging where the hot air hits the board, but I think this should work much faster. So yeah, but as I said, 400 degrees already seems degrees Celsius, it's already on the pretty high side, I would say. So yeah, if anybody who knows what they are doing watches this and has a good laugh, please put it in the comments what I've done wrong. And maybe the idea is just go 500 degrees, go in quick and leave quick before you dry up your solder paste, so that it quickly reflows and then you're already gone before things can go wrong. Okay, so that's it. Right, it was not as successful as I thought it would be, and as I've already shown you, this is the real challenge, taking this tiny bugger off and basically replacing it with a new chip, because that's the PLL clock generation chip, and I think I fried it when I was probing with my scopes, as I told you at the beginning of the stream. Okay, so I don't know if that was helpful. Maybe the beginning with the SMD soldering was helpful. And from then on it went a bit downhill. But anyway, it was live experience, very first time using this thing. I've just taken a few components off before, which is basically easy. You just, wave your hot air and, take your pliers and apply a bit of, tucking force. And as soon as the solder liquefies, you can basically, plug off your parts, no problem. Good. So the question is now, what do I do with this solder paste? It should go into the fridge, probably in a Ziploc bag, that I don't accidentally eat it. No, just kidding. But keep it away from food. Here's the cap that was on, and already a big blob of solder paste still here inside. Good. To be continued, but maybe not boring you with the stream when I continue. But maybe I give you an update when I've done the right column and I'm a bit more confident what combination of nozzle size, airflow and temperature works with this particular solder paste, which is a Chip Quick SMD 291SN LT5, fresh from January. So at least it's